Assalamu alaikum and hi all students. So for today, we will proceed with chapter 4 known as a copolymer. In previous lesson, you have learned that homopolymer are composed of same types of monomer or identical. But before we proceed with this copolymer chapter, at the end of this lesson, you should be able to define copolymer, give the advantages of copolymer instead of homopolymer, state the types of copolymer, and can determine the types of copolymer using chain and model. Copolymer are composed of two or more different monomer subunits linked together to create a polymer chain. Always keep in your mind that a copolymer is a type of polymer. This copolymer also is a type of polymer that is used in wide variety products such as polyethylene vinyl acetate or PEVA, ABS acrylonitrile butadiene styrene, and also nitrile rubber. The process in which a copolymer is formed from multiple species of monomer is known as a copolymerization. It is often used to improve or modify certain properties of plastic. Here is an advantage of copolymer. It can enhance or improve the properties of polymer, such as the chemical properties, physical properties, and the mechanical properties. The properties that might be improved are like durability, flammability, the chemical resistance. Maybe it will lower the melting point or increase or reduce the density of the polymer. Next, we look at the difference in properties between polypropylene homopolymer and polypropylene copolymer as an example. Although the homopolymer properties of existing polymer propylene are good, but it can still be improved by copolymerization. Each of them impart somewhat different but appropriate properties to the product produced. As you can see, this polypropylene homopolymer have a high strength to weight ratio and stiffer and stronger than copolymer, but for polypropylene copolymer a bit softer but has better impact strength, tougher and more durable than homopolymer. So you can see here the copolymer is enhance the properties. Next, we move to the types of copolymer. The first type is a random copolymer. A random copolymer is formed when monomer subunits are linked together in random order. Think of taking several monomers, tossing them in the air, and watching them land on the ground. Wherever those monomers land, when linked together, they will form a unique randomized chain, the one we call as a random copolymer. The second type is an alternating copolymer. Alternating copolymer contain a single main chain with alternating monomers. The third type is called a block copolymer. When more than one homopolymer units are linked together via covalent bonds, the resulting single chain macromolecule is called as a block copolymer. The intermediate unit at which the types between the two of homopolymer chain are linked is called as a junction block. And the last copolymer known as a graft copolymer. which is homopolymer side branches of the types may be grafted to homopolymer main chain that are composed of different mer. The composition of copolymer cannot be determined simply from the knowledge of the homopolymerization rates of the two monomers. That's why you need to use the chain end model, or also known as the terminal model. The chain end model is assumed that the reactivity of the propagation reaction is governed only by the nature of the monomer and of the terminal unit of the growing polymer chain. It also dependent only on the identity of the monomer unit at the end of the growing chain end, independent of the chain composition preceding the last monomer unit, and all propagation reactions are irreversible. So in this slide, the chain end model, so you can assume that how does a monomer repeat unit at the growing chain end tend to react? More of its kind or with another types of monomer? So in general, you have the monomer, the growing monomer chain will react with the same types of monomer. Or this growing chain end monomer can also react with the type 2 of monomer. There is a 4 possible propagation reaction. So either the cross propagation or known also crossover reaction, or the homopolymerization or self-propagation. To predict the copolymer composition, we can adopt by using the monomer reactivity ratio. Which monomer reactivity ratio is the tendency of the two monomer to copolymerize. So there is a copolymerization is classified into three types based on whether the product of the two monomer reactivity ratio. So here in this table, as you can see, the reactivity of monomer 1 and reactivity of monomer 2, if the value is equal to 0, there is preferred to react with the others. So the type of copolymer that produce is alternating copolymer. While when the reactivity of monomer 1 react with the reactivity monomer 2 is equal to 1, so there is no preference, so it will produce a random copolymerization. And if let's say it's above than greater than 1, preferentially at its own kind, so it will produce the block copolymer. And if let's say the value is lower than 1, there is a preferentially adds the other one, adds the others, so it will produce the alternating copolymer. So we proceed with this sample case in order to make sure you will understand more. Case 1 for alternating copolymerization. As you can see, the reactivity monomer 1 is 0, reactivity monomer 2 is also 0. Then both of them will get the 0, so each monomer prefer to react with the other. So it will produce the perfect alternating copolymerization. Then the second one, if let's say the reactivity of monomer 1 is almost equal to 0 or equal to 0, while the monomer 2 is vice versa, so each monomer prefer to react with the other. So it will produce not perfect alternating copolymerization. And if let's say the reactivity monomer 1 is equal to reactivity monomer 2 and it is almost 0, neither monomer homopolymerize very well, so it produces almost perfect copolymer. For case 2, we proceed with random or ideal polymerization. So both of the reactivity of monomer is equal to 1. So the preference is there is no preference. So it will produce the ideal random copolymer. While if let's say the reactivity of monomer 1 is greater than 1 while reactivity monomer 2 is lower than 1, so it will state that one of the monomer is more reactive than the others, so it will produce random copolymer. So if let's say both of them monomer 1 reactivity is greater than monomer 2, it will produce random copolymer, or monomer 2 reactivity is greater than monomer 1, also known as a random copolymer. So if let's say reactivity monomer 1 and monomer 2 is almost the same, so it will produce random copolymerization. And in this case 3, for block copolymerization, both of the monomer reactivity must be greater than 1. So the preference, each monomer prefer to react with other of its own kind, so it will produce the block copolymer. And for your information, this type of behavior is rarely encountered. So here I leave a few problems for you to try to solve. Happy trying to answer. And I already state that the answer for the first monomer. As you can see, the monomer 1 is known as a styrene. The reactivity is 0.8, while monomer 2 is isoprene. The reactivity is 1.68. So for monomer 1, the reactivity is less than 1. Meanwhile, reactivity for monomer 2 is greater than 1. So the types of copolymer produced is a random or ideal copolymerization because monomer 2 is more reactive than monomer 1. So give a try. Thank you. That's all from me. Assalamualaikum.